Good morning, students. Today we are going to see Taylor series and Mclaren series expansion. Okay, first one, Taylor series. We have to take f of x. It's a function. It is infinitely differentiable at x is equal to a. Okay, and you can write your f of x as f of a plus f dash of a by 1 factorial into x minus a plus f double dash of a by 2 factorial into x minus a the whole square plus etc. f nth derivative of a by n factorial into x minus a the whole power n plus etc. This is called the Taylor's series expansion. And in that series, if you substitute a as 0, you will get the Mclaren series. So f of x is equal to f of 0 plus f dash of 0 by 1 factorial into x plus f double dash of 0 by 2 factorial into x square plus etc. plus f nth derivative of 0 by n factorial into x power n plus etc. So using these series expansions, we are going to do the exercise 7.4. Okay, you see, write the Mclaren series expansion of the following function. So here the first subdivision e power x is given. So you have to make a tabular column. Here you have to write function and its derivatives. Here what the function e power x and its derivatives, and you are going Mclaren series means the value at x is equal to 0 you have to find out. So first you take down f of x. What is your f of x? E power x. So in that e power x, you have to substitute x as 0. So what is e power 0? E power 0 is 1. So your f of 0 is equal to 1. Next you have to differentiate f of x. So it is f dash of x. So the e power x differentiation is e power x. So in that you have to substitute x as 0. So you will get the same thing. In the same way f double dash of x. E power x, if you differentiate, you will get e power x only. So if you substitute in the third column x as 0, you will get 1. So you have to write the Mclaren series. F of x is equal to f of 0 plus f dash of 0 by 1 factorial into x plus f double dash of 0 by 2 factorial into x square plus f triple dash of 0 by 3 factorial into x cube plus f fourth dash of 0 by 4 factorial x power 4 plus etc. So in the place of f of x, you have to substitute e power x. You see that f of 0, the first one, it is 1. And this is f dash of 0. That everything is 1 here. So it is 1 divided by 1 factorial into x. Here also this is 1. 1 divided by 2 factorial into x square plus 1 divided by, this is f triple dash of 0 is 1. So 1 divided by 3 factorial into x cube plus 1 divided by 4 factorial into x power 4. So if we expand, it is 1 plus x squared by 2 factorial plus x cubed by 3 factorial plus x power 4 by 4 factorial plus etc. So this is the Mclaren series expansion for e power x. So the next one, it is given as sin x. So in the same way you have to make a tabular column. See, first f of x is sin x. So here you can mention f of 0. Okay, so that means sin 0 was 0, and f dash of x, you have to differentiate f of x, that will become f dash of x. The differentiation of sin x is cos x. So you are going to substitute f dash of 0. So in that you have to substitute x as 0. So cos 0 is 1. The same way, go for f double dash of x. Cos x has to be differentiated. So that is minus sin x. If you differentiate, if you substitute x as 0 in f double dash, you will get minus sin 0, that is equal to 0. And f triple dash of x, minus sin x has to be differentiated. So minus, you just write the differentiation of sin x is cos x. If you substitute x as 0, that will become f triple dash of 0 minus cos 0. Cos 0 is 1. So the answer is minus 1. Next, f fourth derivative of x. So minus is there. The cos x differentiation is minus sin x. So minus into minus plus sin x. So f fourth dash of 0 is sin 0, that is 0. F fifth derivative of x. So sin x, if you differentiate, cos x. So fifth derivative of 0 is cos 0, that is equal to 1. So you have to write down the Mclaren series. What is it? F of x is equal to f of 0 plus f dash of 0 by 1 factorial into x plus f double dash of 0 by 2 factorial into x squared plus f triple dash of 0 by 3 factorial x cube plus etc. You can write. You need not write all the terms. Okay. So here your f of x is what? It is sin x. Your f of x is sin x. So sin x is equal to, first f of 0 is 0. So I have substituted. F dash of 0 is 1. So 1 by 1 factorial into x. F double dash of 0 is 0. 0 by this. 0. 0 if comes, you need not write it, because 0 into anything will become 0. So next one, f triple dash of 0 is minus 1. So minus 1 by 3 factorial into x cube. So f fourth dash of 0 is 0. 0 by 4 factorial into x power 4. This term will become 0. F of the derivative of 0 is 1. 1 by 5 factorial into x power 5 plus etc. It goes on. So sin x is equal to 1 by 1 factorial is 1. So it is x minus, this term will become 0. So minus 1 into x cube is minus x cube by 3 factorial. This term will become 0. So it is x power 5 by 5 factorial. Here I have written minus. So alternatively positive negative means here you will get the next term is minus etc. Okay, so we will go for the next problem. It is a Mclaren series expansion of cos x. In the same way, you have to do the tablet column. Function and its derivative. Here cos x and its derivative. Value at x is equal to 0. So f of x is equal to cos x. We have to substitute f of 0, that is 1. The differentiation of cos x is minus sin x. So when you substitute, it is 0. When you substitute x as 0 here, it will become 0. So minus is a minus, you take out. Sin x differentiation is cos x. So here your answer is minus cos 0. Cos 0 is 1, so the answer is minus 1. So minus has to be written. The differentiation of cos x is minus sin x. So here it is sin x. So sin 0 is 0. Sin x next, if you differentiate, it is cos x. So cos 0 is 1. Cos x, if you differentiate, it is minus sin x. So minus sin 0 is 0. So you have to write the Mclaren series expansion plus etc. has to be written. So here first f of 0 is 1. The next term is 0. So here f double dash of 0 is minus 1. So minus 1 is substituted here. After f triple dash of 0 is 0. Okay, f fourth dash of 0 was 1. So 1 by 4 factorial into x power 4. And here f fifth derivative is 0. So it will become 0. So your answer is 1 minus x squared by 2 factorial plus x power 4 by 4 factorial minus etc. So you can expand the function using Mclaren's theorem easily. So the next one, we are moving to the log of 1 minus x. So your x varies from minus 1 less than or equal to x less than 1. So you have to give the heading function and its derivative, log of 1 minus x and its derivatives, value at x is equal to 0. So the function f of x log of 1 minus x. So in the place of x, you have to substitute 0. So f of 0 is equal to log of 1 minus 0. So it is log 1. Log 1 value is 0. Okay, next you have to go for the derivative f dash of x. So a log of 1 minus x has to be differentiated. You see, first you have to use the chain rule. So for that, 1 minus x as kept as x. So it is in the form of log x. What is the differentiation of log x? 1 by x. So it is 1 by 1 minus x. After that, according to the chain rule, which is kept as x, that has to be differentiated. So 1 minus x, if you differentiate, the 1 differentiation is 0, minus x differentiation is minus 1. So you will get 1 by 1 minus x into minus 1. So you have to substitute x as 0. So in the numerator, 1 into minus 1 is minus 1 divided by 1 minus 0. Minus 1 by 1 is minus 1. So next step, f double dash of x. So here, see 1 by x. the differentiation of 1 by x is minus 1 by x square. So already here you are having minus 1. That minus 1 I have written. If you differentiate 1 minus x again, so you will get minus 1. You see that? First, here, what is that? 1 by 1 minus x into minus 1. So you are going to differentiate this as, so first it is in the form of, you have to keep this as x. So it is in the form of 1 by x. 1 by x differentiation is minus 1 by x squared. So 1 minus x the whole square. Next, according to the chain rule, 1 minus x has to be differentiated. So it is minus 1. Already here you are having minus 1. So you will get minus 1 by 1 minus x squared into minus 1 into minus 1. So if you multiply the numerator, the answer is minus 1 divided by 1 minus x the whole square. If you substitute x as 0, minus 1 divided by 1 minus 0 the whole square. 1 minus 0 means it is 1. 1 squared is 1. So the answer is minus 1. So next one you have to go for f triple dash of x. So what you have to do, see that here you have to go to the, you have to change a sign of it. Okay, so it will become, so otherwise you see now minus 1 by 1 minus x the whole square, isn't it? So first you have to bring it to the numerator. So it is minus 1 into 1 minus x the whole power minus 2. Apply the power rule. So minus 1 into minus 2 into 1 minus x the whole power minus 3, and if you differentiate it is minus 1. Okay, so you will get minus into minus, here also minus. So it is minus 2 divided by 1 minus x the whole power 3. So the answer is, you see that, minus 2 divided by 1 minus x the whole cube. Okay, so see now, here if you substitute x as 0, you will get 2 into minus 1 is minus 2 divided by, if you substitute x as 0 here it is 1. So minus 2 divided by 1 is minus 2. So you will get this. So next step what you have to do, see now, here 2 into 2 divided by 1 minus x the whole cube. Okay, here you are having minus. So how it will be written? Minus 2 into 1 minus x the whole power minus 3. So it is minus 2 into minus 3. If you apply the power rule, minus 3 into 1 minus x the whole power n minus 1. So it is 1 minus x the whole power minus 4 into minus 1. So 1 minus x, if you differentiate, it is minus 1. So therefore your answer will become minus 2 into minus 3. So that is 6. 6 into minus 1, minus 6. So minus 6 divided by 1 minus x the whole power 4. So I have written as minus 6 into minus 1 divided by 1 minus x the whole power 4. If you substitute x as 0, here you will have numerator is minus 6 and the denominator is 1. So therefore it is equal to minus 6. So f fourth dash of 0 is equal to minus 6. And you see here you can use the shortcut. So I have explained how to differentiate using the power rule. Here you can use the shortcut here. See now, 1 by x square, 1 minus x squared, 1 by x, you have to change a sign. Okay, first you take 1 by 1 minus x squared into minus 1. The minus 1 you kept it separately, and 1 by x. So first you have to change a sign. So the sign will become minus and the power will go to the numerator. So it is 2. And you have to raise the power in the denominator. Okay, so that is minus 2 divided by 1 minus x the whole cube. And 1 minus x, if you differentiate, that is minus 1. And here already minus 1 is there, so minus 1. So you will get this answer. Next one, if you differentiate this, what 3 steps you have to do? You have to change a sign. And this power, denominator power, will go to the numerator. So it is minus 2 into 3 is 6 and the denominator power has to be raised. So it is 1 minus x the whole power 4. Again 1 minus x has to be differentiated, that is minus 1. Already minus 1 is there, so minus 1. In this way also, in this shortcut way also you can do it. So 1 by x, if you want to differentiate, so first you have to change, 3 steps has to be followed. 1 by x, if you want to differentiate, 3 steps has to follow. One, you have to change a sign and the power will come to the numerator and you have to multiply with the number in the numerator. So 1 into 1 is 1 divided by, and the power has to be raised, so it is x squared. So the differentiation of what is it, 2 divided by 1 minus x, if we have like this, so 1 minus x the whole cube, suppose if we have like this, so you have to change a sign first, so it is minus 2 and the power will go to the numerator and it has to be multiplied. So 3 into 2 is 6, okay, divided by 1 minus x the whole power, the power has to be raised, and here in the place of x you are having 1 minus x, so 1 minus x has to be differentiated, that is minus 1. In this way you have to do. So 1 by x, if you want to differentiate, the shortcut is you have to change a sign and the power, the denominator power has to be multiplied with the numerator number. Next one, the denominator power has to be raised by 1. Okay, so and that shortcut only I have used here to differentiate. Otherwise you can go for ordinary differentiation. What ordinary differentiation? So 1 minus x the whole squared will go to the numerator, that is 1 minus x the whole power minus 2, and you have to apply the power rule and you can differentiate. Okay, so I have got the values for f of 0, f dash of 0, f double dash of 0. So yeah, I am going to substitute the formula, Mclaren series formula. So f of x is equal to f of 0 plus f dash of 0 by 1 factorial plus f double dash of 0 by 2 factorial into x squared plus f triple dash of 0 by 3 factorial x cube plus f fourth dash of 0 by 4 factorial into x power 4. So you have to substitute f of 0. The previous term we have found f of 0 as what it is, 0. So it is substituted 0. And f dash of 0, what we have found, it is minus 1. So it is minus 1 divided by 1 factorial into x plus f double dash of 0. F double dash of 0 is minus 1. So minus 1 by 2 factorial into x square. F triple dash of 0, what is it? It is minus 2. So minus 2 divided by 3 factorial into x cube. What is f fourth dash of 0? It is minus 6. So minus 6 divided by 4 factorial into x power 4 plus etc. So first term is 0. Next you come to the next term, minus 1 by 1 factorial. 1 factorial also 1. So minus 1 into x is minus x. So minus 1. So here also minus 1 into x squared is minus x squared divided by 2 factorial. 2 factorial means 1 into 2. So 1 into 2 is 2. And minus 2 x cube divided by 3 factorial. 3 factorial is what? 1 into 2 into 3. And minus 6 x power 4. What is 4 factorial? 1 into 2 into 3 into 4 minus etc. Okay, so the first term is minus x, the second term is minus x squared by 2, and this 2 and the denominator 2 getting cancelled, so therefore minus x cube by 3 and 2 into 3, 1 into 2 into 3 is 6, so 6 getting cancelled, the remaining is 4, so therefore x power 4 by 4 minus etc. So this is the expansion of log of 1 minus x. The next one, we are moving to fifth subdivision, that is the tan inverse of x. So minus 1 less than or equal to x less than or equal to 1. Okay, function and its derivatives you have to take. Next one, tan inverse of x and its derivative. Value at x is equal to 0. So you have to do the tabular column. You take tan inverse of x, that is f of x. So you have to find out f of 0, that is tan inverse of 0. So tan inverse of tan 0. So tan inverse tan getting cancelled, your answer is 0. Next, you have to differentiate tan inverse of x, that is 1 divided by 1 plus x square. Okay, so in the 1 divided by 1 plus x squared can be written as, if you bring it to the numerator, it is 1 plus x squared the whole power minus 1. So you will have the expansion. See now, 1 plus x, 1 plus x the whole power minus 1. That can be written as 1 minus x plus x squared minus x cube plus x power 4 minus etc. So here you are having 1 plus, see that, x squared the whole power minus 1. Okay, so how it, in the place of x, what you are having, x squared. Okay, so 1 minus x squared plus, in the place of x, what do you have to substitute, x squared the whole square, so it is x power 4 minus, in the place of x you have to substitute x squared the whole cube is x power 6 plus, here x squared the whole power 4 is x power 8 minus etc. So here we have written the expansion. So what is that? 1 minus x squared plus x power 4 minus x power 6 plus etc. Okay, so in that expansion you have to substitute f dash of 0, that is x as 0. So the remaining term, three terms, the remaining terms having x, so you will get only one answer, that is 1. And if you expand this, it is easy for you to differentiate. So go for the differentiation of f dash of x. So 1, if you differentiate, it is 0 minus x square differentiation is 2x and x power 4 is 4x cube and minus 6x power 5. So all the terms having x. So if we substitute x as 0, so f double dash of 0 is 0. Next you have to differentiate this with respect to x. So minus 2x, if you differentiate, it is minus 2 plus, here 4 x cube, if you differentiate, it is 3x squared. So 4 3s are 12x squared minus 6 into 5 30 x power 4. 6 is a constant. X power 5, if you differentiate, 5x power 4. So 6 5s are 30 x power 4. If you substitute x as 0, the remaining terms will become 0. You will get the answer as minus 2. In the same way, if you differentiate minus 2, it is 0. 12x squared, 12 is a constant. X squared differentiation is 2x. So 12 into 2 is 24x. Minus 30 is a constant. X power 4 differentiation is 4x squared. So minus 30 into 4 is minus 120x cubed. So all the terms having x, so f fourth dash of 0 is 0. Next you have to go for fifth dash of x, that is you have to differentiate it again. So 24x, if you differentiate, it is 24 minus 120 is a constant, x cube 3x squared. So minus 120 into 3 is minus 360 x squared. So you see now here this term having x, so you will get the answer as 24. You can get 3 values, so 1 2 3, up to this you can stop. So I have completed one more. So 24, if you differentiate, 0 minus 360 into 2x. So it is minus 720x. So this term having x, so it will become 0. So plus etc. every step I have written. So when you differentiate minus 720x, you will get minus 720. So the final answer is minus 720. You can stop up to fifth derivative. And you have to substitute, you have to write the formula. Okay. So you see now, first f of 0, what is your f of 0 in this? It is 0. Okay, so the first term 0. Second one, f dash of 0, what is f dash of 0? It is 1. So 1 by 1 factorial into x. F double dash of 0 is 0, so the second term will become 0. And go to the third term, f triple dash of 0 is what? Minus 2. Minus 2 by 3 factorial into x cube. Next term, what has to come according to the formula? F fourth dash of 0 by 4 factorial into x power 4. Fourth dash is 0. So that term will become 0. You need not write it. Okay. So next one, f fifth dash of 0 is 24. Upper 24 by 5 factorial into x power 5. and sixth derivative of 0 was 0. So the next term I have written as 0 here. And come to the next one. So it is minus 720. It is a seventh derivative. So minus 720 divided by 7 factorial into x power 7 plus etc. So here the first term is x. The third term will become 0. Here minus 2x cubed divided by 3 factorial is 1 into 2 into 3. In the same way, this is 0. And come to 24 divided by 5 factorial, 1 into 2 into 3 into 4 into 5 into x power 5. Minus 720 into 7 factorial, what it is? 1 into 2 into 3 into 4 into 5 into 6 into 7 into x power 7. So this 2 getting cancelled. So x cubed by 3. Here 1 into 2, 2, 2 into 3, 6, 6 fours are 24. So 1, 2, 3, 4 up to getting cancelled. So the remaining is 5. In the same way, 6 into 5, 30, 34s are 120, 120 into 3 is 360, 360 into 2 is 720. So 1 to 6 getting cancelled, so the remaining is x power 7. So the answer is x minus x cube by 3 plus x power 5 by 5 minus x power 7 by 7 plus etc. So then last one in the Mclaren series is cos squared x. So you take cos squared x. If you differentiate, first you have to take cos x as x. So it is in the form of x squared. So the x squared differentiation is 2 into x. So 2 cos x. Cos x has to be differentiated. So if you differentiate, that is minus sin x. Okay, so you will get minus 2 cos x sin x. So my 2 cos x sin x is nothing but sin 2x. So you have to substitute x as 0 here. It is cos squared 0. Cos 0 is 1. So 1 squared is 1. So you will get f of 0 as 1. So come to here. If you substitute x as 0, so minus sin 2 into 0. 2 into 0 also 0. So minus sin 0 is 0. So you have to differentiate this. Minus is a constant. Sin 2x, if we differentiate, cos 2x into 2. That is 2x has to be kept as x. So sin x differentiation is cos x. So cos 2x, and the 2x has to be differentiated. So into 2. So minus 2 cos 2x. If we substitute x as 0, minus 2 cos 0. So the answer is minus 2. And minus 2 is a constant. Cos 2x, if you differentiate, it is minus sin 2x, and the 2x, if you differentiate, it is 2. So minus into minus plus 2 2s are 4 sin 2x. If you substitute x as 0, it is 0. And the next one, 4 is a constant. Sin 2x, if you differentiate, what has to come? Cos 2x into 2. That is 8 cos 2x. And if you substitute x as 0, cos 0 has to come. It is 1. So 1 into 8 is 8. So you have to substitute in the Mclaren series and you have to find the result. Okay. So the next one, we'll move to the write down. Second problem, write down the Taylor series expansion of the function log x about x is equal to 1 up to 3 non-zero terms for x greater than 0. Okay. See, functions and its derivative. Here log x and its derivative we have to use. Here Taylor series means you have to take the value at what values are asked. X is equal to 1. So first f of x log x. Here you should not substitute x as 0. Mclaren series only you have to substitute x as 0. But here Taylor series, what is the number, you have to, according to that value you have to find out. Here about x is equal to 1. So you have to substitute f of 1. So you have to substitute x as 1. So log 1. Log 1 is 0. So if you differentiate log this, it is 1 by x. So 1 by x, you have to substitute x as 1. So it is 1 by 1, that is 1. So how to differentiate 1 by x? A shortcut, you know the formula, that is minus 1 by x squared. Otherwise you can use the shortcut. What it is? Sign has to be changed. So I have changed as minus 1. And the new denominator power is 1. X power. The denominator, the power of x is 1. So that has to be multiplied with the numerator number. So 1 into 1 is 1. And the denominator power has to be raised by 1. So it is x squared. If you substitute x as 1, it is minus 1 by 1, that is equal to minus 1. So next step what you have to do, you have to change the sign. So the positive will become So negative will become positive. And the power is 2. 2 into 1 is 2. And the denominator power has to be raised by 1. So that is x cube. Otherwise, you can go for minus 1 by x square. You want to differentiate. So the method is, it is minus 1. This x squared will come to the numerator as minus 2. So it is minus 1 is there. You have to apply the power rule, x power n, that is minus 2 into x power minus 3. So it is minus 1 into minus 2 is 2 divided by x cube. Okay, so in this way only you have to do. So in the shortcut, you have to change a sign, and the new denominator power has to be multiplied with the numerator number. So 1 into 2 is 2, and you have to raise the denominator power by 1. So x squared will become x cube. So you have to write the Taylor series. See that Taylor series f of x, f of a, your a is what here, it is 1. So that's why I have written f of 1 plus f dash of 1 by 1 factorial into x minus 1. So in the Mclaren series you will have x here. Here in the place of x you have to substitute 0. So here x is 1. So f dash of 1 by 1 factorial into x minus 1 plus f double dash of 1 by 2 factorial into x minus 1 the whole square plus f triple dash of 1 divided by 3 factorial into x minus 1 the whole cube. So f of 1 is 0. And f dash of 1 is 1. 1 by 1 factorial into x minus 1. Next one, f double dash of 1 is minus 1. So minus 1 by 2 factorial into x minus 1 the whole square. Plus f triple dash of 1 is what? It is 2. 2 divided by 3 factorial into x minus 1 the whole cube plus etc. So if we expand, so here it will be x minus 1. So minus x minus 1 the whole square by 2 factorial. What is 2 factorial? It is 2. 1 into 2, that is 2. And x minus 1 the whole cube. Here 3 factorial is 1 into 2 into 3. 2 getting cancelled. So divided by 3 minus etc. Okay. So the next one, expand sin x in ascending powers x minus pi by 4 up to 3 non-zero terms. So sin x up in ascending powers x minus pi by 4. So you have to use the Taylor series expansion. So sin x and its derivative, value at x is equal to pi by 4. Okay, so x minus pi by 4, the term has to come. So you have to write the ascending powers of x minus pi by 4. So therefore for that we need the value at x is equal to pi by 4. So first sin x, if you differentiate sin x, that is cos x. Cos x if you differentiate, it is minus sin x. So 3 non-zero term is enough. So I have stopped after this. So here x has what? Pi by 4. So pi by 4 if we substitute, sin pi by 4 is 1 by root 2. And here in the same way if you substitute here x as pi by 4, it is cos pi by 4, that also 1 by root 2. And minus sin x. So minus sin pi by 4 is minus 1 by root 2. So you have to expansion of Taylor series. What is it? F of pi by 4 plus f dash of pi by 4 by 1 factorial into x minus pi by 4. So we are writing the ascending powers of x minus pi by 4. For that we need the value at x is equal to pi by 4 plus f double dash of pi by 4 by 2 factorial into x minus pi by 4 the whole square plus etc. So f of pi by 4 is 1 by root 2. 1 by root 2 is written. F dash of pi by 4 is 1 by root 2 into x minus pi by 4 plus f double dash of pi by 4 is minus 1 by root 2. So minus 1 by root 2 divided by 2 into x minus pi by 4 the whole square plus etc. And sin x, if you expand, it is x minus pi by 4 by root 2. Here minus you will have, so it is minus 1 by 2 root 2 into x minus pi by 4 the whole square. We have written 3 non-zero terms in the ascending powers of x minus pi by 4. Okay, so the next one. So we'll go to the last problem. Expand the polynomial f of x is equal to x square minus 3x plus 2 in the powers of x minus 1. So we have written in the powers of x minus 1. That means x minus 1, the whole square, like that you have to write. For that you have to give the heading function and its derivative. Here f of x the polynomial, so f of x and its derivatives, the value at x is equal to 1. So you take this polynomial x squared minus 3x plus 2. So if you substitute x as 1, it is 0. Okay, and if you differentiate this, x squared differentiation is 2x minus 3x. If you differentiate, it is minus 3. So you have to substitute x as 1 means 2 minus 3, that is minus 1. If you differentiate this again, it is 2. So when you go for the next differentiation, it is 0. So the remaining derivative will become 0. Okay, so you have to substitute the formula. So f of x is what? X squared minus 3x plus 2. In the place of a, here you are having 1. So f of 1 plus f dash of 1 by 1 factorial into x minus 1 plus f double dash of 1 by 2 factorial into x minus 1 the whole square plus etc. I have written the formula. And f of 1 is what? It is 0. F dash of 1 is minus 1 by 1 factorial into x minus 1. F double dash of 1 is 2 divided by 2 factorial into x minus 1 the whole square. Here I didn't write etc. because the remaining derivative will become 0. So the term is completed here. So this is the important step. The remaining expansion we have written plus etc. But the term is completed here. So you should not write etc. So minus 1 by 1 factorial is minus 1 into x minus 1 is minus of x minus 1. This 2 and this 2 factorial getting cancelled. 2 factorial also 1 into 2, that is 2. So if you getting cancelled, so you will get the answer as x minus 1 the whole square. So the polynomial can be written in terms of x minus 1. Thank you, students.